In this video, I'm going to look at a vintage Marconi AM radio. This one was brought in by a client and he requests a full restoration, so we're going to change all of the capacitors in this unit and check it out and see if it works. Should be an interesting one. Warning: extreme danger exists when working on any electronic device with vacuum tubes. Vacuum tubes operate at very high voltages, sometimes as high as 500 volts, and some chassis are hot chassis design and must be serviced with an isolation transformer. Always discharge every capacitor before touching anything to avoid a potential lethal electric shock. So this is a Marconi model 369, it's from 1953, and this is a 6-tube radio based on the American 5 Classic. This one uses 6 tubes because it has a phono input, and those tubes are 12BE6, 12AV6, it has two 12BA6, a 35W4 rectifier tube, and a 35L66 audio output. The 5-tube version used a 50C5 for its audio output because it had one less 12-volt tube. In this case, all the tubes are in series, so when you add up all the filament voltages, it equals your 120 volts. This is an old Marconi AM radio, and it's been brought to me to be overhauled. So we're just going to remove the chassis. Got to take all the knobs off it too. We're going to remove the chassis, and this is a hot chassis. There's no transformer on this. This is one of those AC/DC radio. This is 1, 2, 3, 4, 5. This is a 6-tube radio. Here's the audio output transformer. So this will be directly connected to one side of the line. So this type of radio, very dangerous to work on. Now typically most of these units, the actual chassis was connected directly to one side of the line. In some cases they actually didn't. They actually ran a separate ground wire on them. So not every one of these 5-tube radios, the chassis was connected directly to one side of the line. Let's just see if this one is one or is not. But a lot of them certainly were. So our line cord, there's one side of the line cord there. Is it grounded? So we're isolated from ground on this one. Try the other side here. Measure it to the filter. So it looks like we may be okay on this as far as the chassis itself is concerned. It doesn't look like it's connected directly to one side, although most of them were. Then again, on this set the chassis is isolated, but the only thing protecting the chassis from making direct contact with the line is that paper sleeve that's around the big capacitor in the middle. So we've got greater than 20 mega ohms isolation on this side. So this chassis actually is isolated, which is rare for these type of radios without a power transformer. But what they've got on here is you can see they're running a separate ground because things such as plugs and stuff have got a separate ground lead to them. I bet you, if I measure to this ground lead, I bet you it's got resistance on it. 12 megs. Now the phono input is isolated only through a capacitor, and I'm getting 12 megs of leakage on that. So 35 megs, so that's isolated too. When these capacitors go leaky, of course you lose your protection. That's unusual on these units because usually one side's connected directly to the line, but that's good. Anyway, this radio here we're going to have to replace before I even plug this thing in. And I'm not going to plug it in until I get all new capacitors. So today I'm going to go and source some new caps, and we're going to change all of these paper capacitors out because they're gone. They're shot. There's no way that these things are any good. This thing is so old. What happens on these is they develop internal leakage. In fact, if I put my meter across some of these caps, we'll probably be able to detect leakage in terms of resistance. Let's just put this, 281 ohms. Yeah, that's gone bad. How about this one down here? 29 megs. See, all these paper condensers, they will have gone, they will have shorted. Or most of them will have anyway, especially some of these ones. Now what happens is the paper that separates the foil plates becomes acidic and becomes leaky or high resistant. 17 megs, they're all bad. So I'm going to take inventory of these and we'll get new capacitors, and we're going to replace all the caps in this radio and restore it and make it work. So that's the project for this video. This is, check out our AM antenna. Just a coil of wire on the back. Okay, let's start replacing capacitors. As you can see, I went and I got a whole stack of new ones. So we've got new caps for every one of these paper caps, and I do have a couple of electrolytics that I can use. So we'll start by removing and replacing all of these paper condensers here, the ones that give us the most trouble. This is an electrolytic, this is a dual electrolytic, so I'll be replacing this with two separate capacitors. They both go down here to this black wire here. So, I'll get my soldering iron warming up here, and I'll just start and we'll work our way through here. Now, like before, a lot of these capacitors have got an outside foil, so we need to make sure that we put them in the correct polarity. And we'll do that, as I've shown you before. We'll use the oscilloscope and we'll check for the noise floor. When you're connected to the scope, when your center or when your ground is connected to the shield, you'll have less noise than if your probe is connected to the outside foil, because then what happens is the outside foil tends to act as an antenna and pick up interference, which will show up on the scope. And I've demonstrated that before. I'll briefly show you again how we go about determining that. So anyway, this one here is a 0.005. So let's find that. And I couldn't get the exact value, so this one will be replaced with a 0.0047, but that should be more than adequate for this. Here's a 0.0047. Because this is an AM radio, so the values of the capacitors are not critical. As long as you're in relatively close to the original, it's going to work fine. So if we look at the scope here, we'll see that there's relatively little ripple there, and then I'll reverse the leads. And we'll see that there's considerably more ripple, right? So there's the noise we're getting here. So obviously this is clipped to the outside foil, because here's our noise floor here. Our noise floor is less in that direction. Therefore, this is my outside shield here. This is my outside foil. So now what I'll do is I'll mark the capacitor with a mark on here just to tell me that that's the outside foil for this one. And we'll do that for each of the capacitors before I put them in. The reason why you need to do this is a lot of times these capacitors are used for coupling. So you want the outside foil to be going to the ground side. Otherwise, if you have your outside foil going to the side that's on your grid for the tube, for example, any noise that's being picked up in the air by that outside shield is going to be coupled directly into your circuit. You want to couple that to ground. So we'll replace all these caps. Look at the size of this thing here. This is a 25 volt, 25 microfarad. Look at the size of that thing. It's going to be replaced by just a little tiny electrolytic. Anyway, let's remove these old capacitors. There's several ways you can remove them. I prefer just to use my side cutters and just cut them. Right now, I'm sure I'm probably going to hear from someone that says, you know, that's not the way to do it, but sometimes you can unwind them as well. But I find it's just as easy just to clip them off. And then when we heat up the tab here, I should be able to put the component through the hole in the tab and resolder it down. Let's get some good leaded solder. Not use this lead-free crap that came in another kit. Many times you can heat them up and just unsolder the old ones and just remove them too. That's another option. Like that. Put the new cap in, solder it down, and then we'll bend the lead around and clip it off. So that's one done. And yes, I will be testing this unit and playing some music from my AM transmitter that I built, so we can actually hear what music sounds like through one of these radios, because of course with no broadcast AM stations around anymore, well, I have to make my own, right? Okay, this one here is a 0.05, 500 volts. Let's find the 0.05. Is that it there? Nope. One. This is it here. As you can see, these new ones are much smaller than the originals. Again, I'll figure out which way this goes in. Now this one here, because this new capacitor is a lot smaller, I'm actually going to have to just cut the leads and cut them close to the cap itself. And we're going to have to just extend the lead a little bit here so that I can splice it. It's going to remove this bit of insulation. I'm going to splice this line on here, and then we'll take it over to and splice it over to this other wire. So I'll splice it to this one first. Need a little bit more length. Okay, that's better. Now I can twist these together and solder them. Put a little hook at the end of the wire so that the two can be hooked together. Go. And see, this insulator is here so that it doesn't short out against this other post. This is actually a coupling capacitor. This goes to a plug here. Looks like maybe it's a phono input, and this is to isolate the ground. This is actually on the ground side. Okay, that one's done. Next we'll do this 0.003, this little cap down here. Just going to find one here for it. Here it is. It's not quite the right size. I couldn't get the exact size, but it's it should be okay. It's just a coupling capacitor. So we'll remove this one. And this one's not marked which side is the foil side. If there is one. Oh yes, should be this side here, I think. Let me just double check it. So this was the foil side here. So we're going to put this one in. And I've identified this one and I've marked it. So we're going to put this one down in here. Okay, that one's done. Got one across the AC line down here, which is underneath this plug. I'll just clip this one out of here. The other side of that one is this wire right here. And that's just across the AC line itself. So it's not really doing anything other than maybe taking some coupling some noise out of the AC line, taking out any RF that might be coming down the AC line that could get into the audio. So that's all this is doing. It's just bypassing any RF. It's a 0.25 at 500 volts. So what do we got here? 0.25. I have a 0.27. I think we're probably close enough on this one. But I don't think polarity is really going to matter on this one, because outside foil or not, all this thing is doing is it's just going across the AC line cord. So we'll just put this thing, and this is the same with this other one here. This is just a 25 volt, 25 microfarad capacitor. It's just going to one side of the AC line. Okay, that one goes around the AC plug. We'll just solder that one in place. Okay, that one's done. Got 3 more to change out, plus this big electrolytic here and this one. So this next one, we'll change this one here. I guess this is probably, I think this is probably the volume, maybe the tone control. No, that'd be the volume control. That one's going to be the tone control up here, I think. This tone, this is volume. Let's get the power switch on it, so I think that's probably volume. Anyway, let's take this one out. This is a 0.01, 500 volts. We'll check our outside foil. This one's actually installed backwards. Or was it? No, I guess it wasn't. They had the outside foil to the center tap here, but if we look at the center tap, it actually goes down to the switch on this thing. What the heck? The center tap, if you look at this control here, let me move this camera because the way this thing's wired, it just doesn't, it boggles the mind. Check out the wiring on this thing. Like, you wonder how this thing could even work. Here's the center tap of our volume control, and look at where this bridge wire is going. It's going right down to the AC switch. We have one side of the AC line connected to the center tap of the volume control. Isn't that crazy? Unless that's a tone control, and then that would make the other one the volume control, but I don't know. This is the tuning knob up here. See, we have these other controls. This one might be the volume control over here, and this one might be tone. Anyway, the way that cap was connected, the center or the outside shield, outside foil was going to that terminal there, to the middle terminal. So that was the, or was that was the 0.01, right? I'm going to be servicing my Holocrafters radio here at some point in the next little bit. I've got an old Holocrafters, and I'm going to put all new caps in that too, because it hasn't been used in a long time, and I like to get it working. Once again, outside foil is that side. And then we got this one big last one to go in here. Oh, of course, these other ones with the electrolytics, but this is the last of the leaky paper caps. This is a bypass cap that's going to ground. So obviously the outside foil has to go to the chassis here. This one's a 0.1. And we measure this one to make sure. All the ones so far have all been labeled on the correct side, but you never know, right? You might find one that is the opposite. And this is such one. Take a look at this. So here's my noise. You can see the noise on the scope there. Okay, so this is obviously my outside shield here. The noise is considerably less. So this is my outside shield, and as you notice on this one, it's on the right side of the labeling. The other ones I've already done, they were on the opposite side. So you basically have to check every one of these capacitors, every different brand. Like if you get same capacitors from the same manufacturer, then chances are they're all going to be good. But if you get different brands of caps from different manufacturers, you don't know which side they've put the outside shield on. Therefore, you do have to check it. It is important. If you don't, it's still going to work, but it's just that the chances are the radio is going to pick up a lot more hum just from induction, right? So that's the reason you check it. And I haven't got quite as elaborate as Paul has gotten on his channel by building a little device that automatically he just puts the cap in there and it switches back and forth. I haven't gotten quite that elaborate doing the checking because, you know, it's easy to do it, but just the scope takes 10 seconds, so I don't need to go to all the hassle of designing a circuit to switch it for me. I was thinking though of making a little metal box and just having a toggle switch on there, a double pull, double throw switch to reverse the clips, and then you could just flip it one way or the other. Okay, which side is which? That would be just as effective doing it that way. This lead is not quite long enough, so I'm just going to solder it down to this other one that's already here. Okay, that's got all the paper condensers swapped out. Let's go get a couple of electrolytics and we'll replace this three. This one connects to this black wire here, right? Which is also going to one side of the, this will be the chassis ground. One side of the AC line cord is going to this capacitor. I'll go grab three to replace these. Of course, these ones came out of an old switching power supply, one of those little power supplies like for a modem or a cable box. I think this one probably came out of a modem power supply. These are 68 microfarad, 450 volts. They're going to do the job just fine. They're just AC line filters, so we'll remove this one first. Actually, we'll do this one first. Do these ones first. I'll have to put some heat shrink tubing around to insulate these ones as well. But we'll put the two 68s. I'm going to connect the two negatives together because we're making this into a dual capacitor. So we'll connect the two negatives together here. That way we can connect it to the ground wire. I have to use heat shrink obviously on this because this is going to have high voltage. These are going to be the main filters for the radio, and they're going to have high voltage on them. We're going to bring this heat shrink up as far as we can here for the ground wire. And we'll heat it with the heat gun. I'm going to try and fit this in kind of the way that the other one was, so that my positive leads will face like this, so that I can connect the wires here directly to the terminals. And of course we'll put some heat shrink tubing over them, obviously, to insulate. That can be quite long enough. I'll have to extend that lead a bit. Put a little hook in the end of the wire to hold the wire together while we solder it up. Okay, that one's covered. Seal it up here. Don't want to get too hot. Not hot enough to melt the metal anyway. Just hot enough to melt the heat shrink. Keep it from coming undone. We'll do the same for the other wire here. This one's got a little bit left on the end there, so we'll just nip off some heat shrink tubing. There we go. That's better. Okay, that'll be okay. Okay, that'll keep that one from shorting out to anything. We have one more to put in here. Cut this one out of here. So the positive goes to this side over here. The negative goes over to, actually going over to the line cord over here. So we'll put this one in here kind of, I guess we'll mount it down to here. I'll mount it down to this. Okay, so that's that one. It's got to get another lead to go over to here, to the line cord side. It's actually connected to the same as this wire here, right to this capacitor. So it is a filter that is in there. Heat shrink tubing around this as well, just for safety. Okay, well, now just connect the negative here back over to the convenience outlet on the back, and then this radio should be ready for testing. Okay, everything's connected, nothing's touching. Let's turn this thing over. We'll apply power and see if we can pick anything up on it. Shall we try it? I'm almost nervous to turn this thing on. Oh.
There is, if you can play well, this is where the big money start rolling in. Those four World Golf Championship events are no-cut events.
And you should be able to see them open up the pack.
Okay, this is a tone control.
Or sterilized needle.
That's a tone control.
And they have to do maximum sterilization. They have to follow this procedure.
I think the controls need to be clean, so I'm just gonna unplug this thing. We're just gonna clean the controls here, and then I'll put my little AM transmitter on, and we'll put some music on it, and we'll tune it in to see how it sounds for music. Let me just clean the controls first. To show I'm not partial to any particular cleaner, because I use deoxit as well, but I'm going to use Neutral on this one. So we'll just give this control a shot. This is the tone control. This is the input switch, by the way, for phono and radio, because it does have a phono input. And we'll give the volume control over here a shot. Okay, I'll reattach the antenna backboard to it. We'll get the unit into its cabinet, and we'll test it and see how it sounds. Okay, we're going to listen to some music here. Just going to turn this thing up a bit. I'm going to play this. I got to go to the other room because my little AM transmitter I built is on the other side of the house. I'm going to go turn it on now, and we'll play some music through this thing. Control still needs some cleaning. clean that switch. You gotta take it apart again and clean the switch. So there it is. I only had the one song queued up to play. There it is. It works. And that's one of the prime reasons I built that AM stereo transmitter, was for testing my AM stereo radios, but also because I'm seeing a few vintage radios, and I'm likely to see a lot more as I've started to repair vintage stuff. And there's only one guy around that does it right now, and I'm going to give him some competition, because there's a bunch of these vintage radios out there that need some TLC and need cap jobs on them. And we're going to try and restore as many of these old units as we can, because they don't make them like this anymore. This is a piece of radio history, and we want to preserve these as best we can. This one here, as you can see, has been quite badly abused. The cabinet is not in very good shape, but you know what? That all could be easily cleaned up. Refinish this thing would look great. Let's just see what we get for broadcast stations on here. Again, I'm going to get a lot of static, a lot of noise because of the lights. I have fluorescent lights in here, and I've got electronic ballast, so they really create a problem for noise for AM. Even on the little signal that I'm creating, the hum there, that's not the transmitter, that's actually just noise.
Agreed, Steve. Thank you. Time now for the opening kickoff.
There we go.
Brought to you by Warner Letters. Hey, football fans, Warner is kicking off.
Ja, nog e-box spons.
Favors saying it's an easy scapegoat for a complex litter problem.
They could actually China trip rolls on with the...
Away $1,040 cash every weekday for 20 straight.
The interior. Police in New Westminster are searching for someone they described as responding with significant rage.
East lane blocked.
I believe the light bulb just came on. The light did come on. I thought the light bulb was burnt out. I think it is. It probably just decided to come on. Either that or it's loose. Yeah, you can see the pointer is actually... Watch here. The actual dial pointer is actually... The light bulb protrudes, and as the pointer goes by, it actually goes over top of the light.
Either direction.
Anyway, this unit is fixed. Thanks for watching, and we'll catch you again in the next one real soon. I'll show you what I've got coming up too, just so you guys get an idea. I bet you guys have never seen one of these. What do you think? You notice the brand? Has anybody ever seen that logo before? I know you've seen the brand, but have you seen that logo? That's a Sony. This is the transistor, is it 6? Transistor, it just says transistorized. It's either 6 or 7 transistor. Anyway, I thought the Sony Transistor 6 radio that I own is old. Mine's in a plastic case. This one is wood. This is coming up, so you guys can drool over this, because this will be one coming up real soon. We'll catch you in the next one.